Good morning, good afternoon, and thank you for joining today's webinar hosted by Accelalpha. Today's topic is BOM mapping. It is one of the new features available in the latest released 2016 R1. We'll discuss how this new feature works and how you can set it up to streamline your business processes. I am Devang Bausar, and I'm the CPQ lead at Accelalpha. I'll moderate today's discussion. I'm joined by Rob Bruzina, CPQ architect at Accelalpha. Rob has years of experience implementing CPQ for various verticals. He truly understands the challenges involved when integrating front office and back office systems. Today, he will help us learn how the new BOM mapping feature can make this integration easier. A few housekeeping items. All participants are put on mute. So please use the chat window for any questions that you have, and we'll have a Q&A at the end of the webinar. If there are any questions that you are not able to get to, we'll respond individually after the webinar, and we'll also be recording this presentation, so we'll share the link via email afterwards.
Thank you for that introduction. Hopefully everyone can hear me okay. Again, my name is Rob Brozina, and I'll be going through the BOM mapping feature that came out in 2016 R1 in CPQ with you today. So, just the agenda for today, we'll be going through an overview of the new functionality, talking about the benefits of the BOM mapping, kind of setting the tone for the rest of the presentation, right? We'll be touching on those benefits throughout. Then we'll dive into the details of the functionality, starting with the specific tables and the table relationships, and then going into an actual example. So you'll be happy to know that we built a pizza configurator that we are generating a BOM for. And then once we go through that example and go through all the different functionalities, we'll provide a little bit of guidance for existing customers and end with Q&A at the end. All right, so I like to start from base principles and just sort of build up concepts that way. So let's start with, what is a BOM? Wikipedia definition of a BOM is a list of raw materials, sub-assemblies, intermediate assemblies, subcomponents, parts, and the quantities of each needed to manufacture an end product. That's a mouthful, right? But it's basically a collection of components or items and that are needed to manufacture. And those items can be hierarchical or multi-level. So the relationships could be complex, right? A part might have a subpart, that subpart might itself have subparts, so on and so forth. When we say the word BOM, we can mean one of two things also. It could either represent the universe of all possible ways a product can be manufactured. So sometimes that's called a skeleton BOM or just the model definition in general, or we might be talking about an individual instance. So I think it's important to kind of keep those two terms or those two concepts separate in one's mind, because we're going to be talking about both really here. A BOM, unlike what Wikipedia says, it's not necessarily only for manufacturing either. It could be for sales as well. So you might have a sales BOM that's different than a manufacturing BOM. So the way that you present a product and its line items to a customer on a quote, for example, might be different than the way you present that same product, or the way you manage that same product for manufacturing. The lines that you need for quoting might be different than the lines that you need for manufacturing. And the new BOM mapping functionality allows you to do both. Another thing about BOMs is that if you have a BOM, if you're a company that manages BOMs, you're typically already managing it in your ERP system, because you need to be able to build it. You know, the ERP system, which sort of manages the manufacturing process, needs to know how the relationship between the parts to be able to actually control that process. So one of the problems that this BOM mapping functionality solves is how to provide a standard mechanism to export that model definition, that BOM definition, out of your ERP system and load it into CPQ. for use in both in quoting in terms of a sales BOM, but also for manufacturing in terms of generating a valid order out of CPQ at the point when you're converting a quote to an order. Because that's always the goal, right? Converting quotes to orders. So, like I alluded to, we'll be going through an example of a pizza. Those of you that are existing CPQ users, you should have a little smile on your face because you've gone through the historical CPQ training, which makes you build a pizza configurator. So we've done the same thing here as kind of an homage. A pizza is, I think, a good use case because, well, everybody understands pizzas. Not everybody understands pumps or test equipment or rotary dies or what have you, but everybody understands pizzas. Pizzas are made up of a crust. That crust might have a bunch of ingredients in it: yeast, sugar, water, flour, salt, and so on. There's a sauce on top of that pizza. Before you shoot me, there's a good reason why I use that Alfredo sauce instead of tomato sauce. I wouldn't dare eat a pizza with Alfredo sauce myself, but I wanted to demonstrate that Alfredo sauce is a little bit more complex than a tomato sauce. And Alfredo sauce has butter in it, cream, Parmesan cheese. Its ingredients themselves have sub-ingredients. So you see that butter, it has cream and salt, and the cream itself is made out of milk. Or the Parmesan cheese is made of milk, rennet, and salt, and so on. The pizza also has toppings on it, like cheese, pepperoni, mushrooms. This cheese also might have its own subcomponents, so on and so forth. Now, what we see on the right side is both a sales BOM and a manufacturing BOM. The manufacturing BOM is the whole thing. The sales BOM are the gray highlighted rows, right? The things that we want to actually present to the customer, the things that potentially affect the price, and so on. The key thing to understand is that CPQ, with this new BOM mapping functionality, is able to generate both. All right, so I wanted to quickly go through some of the new things that are part of this functionality that we call BOM mapping. The first is there's a set of standard tables that are used in BOM mapping. We'll go through those tables in detail in a moment. There's also a separate new configuration rule type. It's called a BOM mapping rule, and we could see it on the right side in our product hierarchy where we have all of our attributes and rules. We see a BOM mapping rule there. There's two of them in our configuration. There's also a series of system attributes that are used to store the result of the BOM and different details of the BOM. And these are available to us for presenting to the user or for querying from formulas and rules and so on. There's also a really nice set of JSON BML functions. So the BOM itself is generated as a JSON object. And so with that, we get a bunch of nice JSON functions for manipulating JSON objects, for creating, parsing JSONs, and so on. So not only is this very useful for BOM generation, but this is also very useful for integration with end systems. So more and more systems, I think, or integrations are written with JSON in mind instead of XML or SOAP. Also, some of the new RESTful web services that CPQ has are JSON-based. So these functions are going to make it a lot easier to parse those as well, in addition to working with a BOM. There's also a BOM, some BOM BML functions that we have. The most important one here is the get BOM, right? So this is the function that we would call when we're integrating with a fulfillment system in order to get to the manufacturing BOM, for example. And then we would use those JSON BML functions to potentially transform that JSON into an XML, for example, before sending it off to the order management system. And there's also a series of administrative pages that are part of it that we'll be going through in a little bit of detail throughout this presentation. So let's talk about some of the benefits of BOM mapping, BOM mapping rules in CPQ. One of the major goals with BOM mapping was to make it easy to integrate your BOM or model definitions from ERP with CPQ. So there are standard tables and standard schemas in CPQ that are generic enough for you to be able to import data, BOM definition data from your ERP systems into CPQ. Now, it might take a little bit of transformation, a little bit of augmentation of that data, but the idea is that gone are the days of dual maintenance of your model definitions between ERP and your quoting tool, CPQ. So now the idea is that you're managing your model definitions in ERP, exporting them and loading them into CPQ, so that when your model and your BOMs change in ERP, we're also changing them in CPQ automatically. So we're reducing that dual maintenance. And it also, of course, ensures data integrity and consistency, right? When you're not maintaining the same thing in two places, but instead sourcing it and mastering it from a single place, you're gonna minimize the amount of data errors that you have. Of course, all of this also minimizes implementation time. The BOM mapping functionality is largely automated. It's almost like magic, to be honest. And we'll see this when we're going through the example. But if you load up the data from your ERP, or if you're creating the data in CPQ, as long as that data is correctly formatted and it's loaded in CPQ, you press a button and BOMs are generated. So it's really minimizing the implementation time. Keep in mind that historically, you're always able to generate BOMs in CPQ, and many of you on this meeting today, I've personally helped some of you generate BOMs out of CPQ. But now we're really getting a nice, standardized, automated, data-driven way to do it. Now, we talked a lot about how the BOM relates between ERP and CPQ, but really, given that the BOM mapping functionality can generate both a sales BOM and a manufacturing BOM, it's the sales BOM component that could potentially be standalone in CPQ. So maybe you're a company that doesn't really have a manufacturing BOM. Maybe you sell software, for example, but you still obviously have a sales BOM in that you have line items that have prices, right, that are based on items and so on. And so you could use this BOM mapping functionality just in CPQ in order to generate your line items for your quote, to generate your sales BOM. Okay, so talk a little bit about the benefits. Now we'll jump to the details around the tables, the standard tables that we have now in CPQ. So we'll start on the upper left. I sourced this image actually directly from the Oracle's documentation. There's an implementation guide for BOM mapping that they put out that's really good, really detailed, and this is a nice picture. I also added a couple relationships here with those red arrows that I think are going to clarify the discussion here. So we'll start at the upper left. We have our BOM item definition. This is the table where we define all of the items that are in our BOM and all of the possible items, right? So this is really our universe, using the term that I used before, right? So here's where we relate items to other items with the parent-child relationship. So every item that's not a top-level item is always related to its parent. And there could be any number of levels here. There's no limitation. The items themselves are then mapped to configuration state using this table, the BOM item map table to the right. And so this is the table that translates configuration attributes and their values to items. So if, for example, given our example of a pizza, right? If I select Alfredo sauce in an attribute, in that item mapping table, I will have that attribute with that attribute value mapped to my Alfredo sauce item. And then the system uses the BOM item definition table to understand where in the hierarchy that item that I just added belongs. BOM items can also have attributes. These are attributes that are different than configuration attributes. These are BOM attributes. This is like metadata on top of the item. So something like size, for example, size of the crust, small, medium, large. Those could be attributes of a generic crust item instead of having separate items for those different sizes. Another example would be maybe crust type, deep, thin, or pan crust. Now, just like items are mapped to configuration state, so are the attributes. So we have a table, the BOM attribute map, that relates the configuration state to understand which attributes to apply under certain conditions, and it has the ability to map those attributes to both BOM attributes, but also to line item attributes, and we'll see how that works later in the presentation. What's interesting is that the attributes can also be translated, and so those translations, translated values can be used in the UI, or they could be used in the integration. They can be available to us. Now, not all these tables are necessary, right? At a bare minimum, in order to enable table-based BOM generation, we need the BOM item definition and the BOM item map. If your ERP system supports attributes, then we would need the BOM attribute definition and attribute map tables. And if you want translations, we could add the translation table as well. All right, so moving on. One interesting thing about these tables is that well, first of all, this view, this is a screenshot of our translation table. And so each table has, the system expects certain columns to exist. But the table doesn't necessarily need to be generated or sourced from CPQ. It can be. If you're starting from scratch, you could download a sample, and that will download a CSV sample that then you could fill out or use just as a template for when you're transforming your ERP model data into the template that CPQ expects for loading into CPQ. But if you already have some existing BOM tables or existing table structures that might be reappropriated for this functionality, you could do that. So it's possible to load, or I'm sorry, select a table that you already have, and then for each of those columns that CPQ expects, you could then point it or map columns of the table that you selected to the columns that CPQ expects. So you could really use any table. The column names could really be anything, and this really gives you the ability to reappropriate existing data. Again, minimizing implementation time. All right, now we'll go through some examples. We'll start with the BOM item and attribute definition tables and how they're represented in CPQ. So we'll start with, there's some new administrative pages that you could use to navigate to see some of this stuff. So under admin, if you're an admin and you log into CPQ, under the items section, there's a new BOM link that when you click, you're presented with these links, and we're going to go down and we're going to look at the BOM root items list. Clicking on that reveals all of our root or top level items. In this case, we have a pizza and a calzone, which is nothing more than a folded pizza. Clicking on pizza will reveal the kind of the UI representation of the BOM item definition table. This is just the first 17 rows here because my entire skeleton BOM didn't fit, and I wasn't able to screenshot the whole thing. So it's only a portion of it. Notice that the system presents it in kind of a hierarchy. Here is the data that actually is represented by this view on the left side. So right away you notice the system is able to present to the user, the administrative user, messages if there's any errors with the BOM data. So in this case, we see that we have some problem with our crust, and it's probably the name of it, or the part number is missing a T. And so we see in our data that the part number is missing a T. So that's kind of a beautiful thing, I think, about the application, that given the data, it will automatically validate the data and actually guide the user towards what the problem with that data is. It'll show kind of targeted messages, and we'll see some of those targeted messages. And these kinds of messages, we'll only see a few examples of this. These messages are all over the place. So there's nice internal sort of validation to make sure that data is consistent. Now, the first thing we'll notice, again, on the right side, this is our BOM item definition table. Each item except for the top level items, needs to be related to a parent item, right? So a crust, the crust's parent is pizza, yeast's parent is crust, and these are all the things that make up the crust. And then we have the all-purpose flour itself has some subcomponents and so on. So the table is flat, but it's actually represented hierarchically in the system, right? So the system takes this, parses this table, and understands where each item lies where in the hierarchy. Each item can also be either a sales item or a manufacturing item. So you see that represented in the BOM item definition here as well. It's a simple yes or no. And so the item could be both as well. It could be either or both. Now, if we drill down into crust, here, we'll see a more detailed description of the error. So it says that this part number does not exist. So we fat finger that part number. But we also see at the bottom any attributes that we defined for this item are also displayed here. And if there were any problems with these attributes, we would see that here as well as errors. So here we have a screenshot of the table. Again, we have a size and type attribute that is related to crust. And so we see these two attributes when we're looking at the detail of the crust. Now let's go through some examples of actual BOM item mapping. So here's our pizza configurator. It's comprised of a series of attributes, and we're going to go through how each of these attributes relates to specific items and BOM attributes. And we're going to start with items. So we'll pull up our item table on the right side. First of all the BOM items that don't have any mapping, that implies in the data, that implies that they're generated automatically all the time. So if there is no mapping, they're always generated. Now, here we see a relationship between our sauce attribute and the items that need to be added as part of that sauce. So here we have the attribute name, sauce, and the value, Alfredo. So if I select Alfredo, automatically I'm going to get all of these parts as part of my BOM. And these parts, again, are a mix of sales BOM and manufacturing BOM parts. It's as simple as loading this data in this format, and the items are just going to be generated automatically. We see our topping as well. So we have a topping attribute. If it's cheese, we add the cheese. Notice that for those people on the line that are existing customers, I'm going to come back to this and talk a little bit about why this cheese and its child parts need to be separate attributes. But array attributes can be mapped to BOM items, just like regular old attributes can be mapped as well. Here we see our pepperoni and mushrooms, also generating our pepperoni mushroom corresponding items, and dipping sauce. If it's set to true, then we're going to get a dipping sauce item on our BOM. Totally data-driven, no BML, no scripting required. Now we will talk through, I wanted to come back to this sauce attribute because I think this is a really interesting use of BOM tables out of ERP. This sauce attribute is actually the values that are possible, Alfredo, tomato, and so on, they're actually sourced from a BOM table itself. So this is actually a fairly new type of attribute that we have in CPQ called a single select pick list, where you can tell the system to source the possible values for that pick list from a table, and you tell it which column from that table you want to use, and you give it a filter on that column. So I'm using the BOM item definition table, and I'm filtering all items where item type is sauce item. And I'm using that to populate this item attribute. So if you have an attribute that is sourced from the same table that is used to generate items, then you have that guaranteed internal consistency. And if the items change, then the attribute automatically changes, and it really minimizes the amount of dual maintenance that you need. You know, when your menu attributes change, because they're going to change automatically based on the data. I'll let that sink in for a little bit because I think that's really cool. We're going to come back to this later as well. So we talked about BOM item mapping. Now let's go through how BOM attributes are mapped. And it's a very similar process with very similar similar tables. So we're back in our pizza configurator. Now, instead of our item mapping table, we're looking at our attribute mapping table there at the bottom. And again, we're going to go through it one by one. So our quantity configuration attribute, whose variable name is quantity pizzas, it is used to control or map the quantity. So whatever number I input into this attribute is going to be dropped into the quantity for my top level pizza item. So ultimately, the attribute mapping, the way it works is you're telling it, first of all, what attribute you want to target. It could be quantity, it could be just a BOM attribute, or it could be a line attribute as well. What are you using as a source? In this case, you're using a configuration attribute, or quantity pizzas, and which item this should be applied to. And in this case, we're doing pizza. Another example, size, right? In this case, instead of mapping to quantity, we're mapping to a target BOM attribute, which is the size attribute on the crust. Crust, same thing. We're mapping to a BOM attribute. This time it's the type attribute, and we're using the crust configuration attribute. Dipping sauce type, very similar, right? BOM attribute type, and we're dropping the value that the user selects in the dipping sauce as a BOM attribute. So that attribute then will be in our BOM definition that we could use downstream for fulfillment. So BOM attributes could really be any data that augment the BOM. The data could be useful or necessary for sales or for manufacturing. Another type of BOM attribute mapping is this static type. So instead of using a configuration attribute value, we're using the fact that well done is checked and the value is true in order to drop a static value into a BOM attribute on the pizza. So if a user checks this, then my pizza line item is going to have some metadata on it that says bake extra 5 minutes. And so that can be used in fulfillment. Doing a similar thing with delivery instructions, right? We could type in the fact that we want the delivery driver to use the back door, and we could drop that into a BOM attribute as well. We could also use attribute mapping for dynamically setting the price. Now, by default, the sales BOM price, the price of a BOM, is the sum of the price of its parts. And the price of the parts, as well as the BOM, are sourced from the same place. They're sourced from an ERP system. But if we want to kind of break that mold, and oftentimes we do, we could use BOM mapping to kind of overwrite the standard item price and kind of implement dynamic pricing there. So in this case, we are mapping this base price configuration attribute, which we're dynamically calculating this price, which is based on combination of size and crust type, and dropping it into a line attribute. And we're going to see this line attribute later in the presentation. And again, that's going to be used for dynamic pricing. We have a few more examples of using the array. So for each of our toppings, we have a coverage, whether it's whole or half the pizza, and we use that to populate a BOM attribute. And we're also populating pricing for our toppings, because the pricing in this case, if it's a half a pizza, it's 50 cents, and if it's a whole pizza, it's $1. Now, if we had a part, a separate part for topping for whole coverage and a separate part for half coverage, then those parts could have these individual prices. Then we wouldn't have to do this kind of dynamic mapping. We would simply add the correct part based on the coverage. But you know, there's different mechanisms that are available to us to achieve the same end. There's flexibility built into the system. And again, all of this takes, in order to do this BOM mapping, is filling out these data tables or sourcing these tables from external sources. There is no scripting, no BML that's required. It simply works. So we've gone through our configuration. Let's now save our configuration and see the results, what line items we're actually going to get as a result of this configuration. So we drop, here is a representation of our line item grid. In CPQ, we have a bunch of line items. Notice that the items that end up as line items are those that are marked as sales items. So on the right side, this is again our BOM item definition. Again, this is the table that kind of describes the universe or the skeleton BOM, all the configuration of the parts that are possible. And those parts or components that are marked as sales item, those are the ones that end up as line items on our sales BOM. Also notice that those that are marked as optional can be deleted by the user. So this works in much the same way as the traditional recommended items work. Optional recommended items can be deleted while mandatory recommended items cannot be deleted. Same thing with BOM, sales BOM items. It works the same way. Also notice the quantity. So the BOM quantity, this is one of the extra attributes that comes out of the box when we upgrade to 2016 R1. The BOM quantity is by default sourced from the item definition table. So for every single item definition, we have a standard quantity that is also defined. And as we saw, we actually mapped our configuration attribute for number of pizzas to the BOM quantity on that root pizza line or part or component. And so that one's set to 2 while the rest of them are set to 1. Now our actual line quantity is then exploded. And this is actually by design, this is automatic, this is out of the box. So in order so that all the pricing works out, if we're buying 2 pizzas, and given that the price of the sales BOM is the sum of its components, then we explode out that item quantity down to the individual lines in order to get our total price. The item descriptions are typically sourced out of the items database in CPQ, which itself is typically sourced from the ERP. So we have kind of 2 things that are normally sourced from the item database in the ERP. The individual item prices, which can be overridden, as we've seen through dynamic mapping, and these descriptions. The descriptions can also be overridden, of course, through mapping. So here we have an example where we're dynamically generating a description for this crust, saying that it's large and thin based on the user selection. This could be done, of course, through the table-based mapping rules that we saw. But we're going to come back to this actually, because there's another way to do this, and there's another way to kind of manipulate the BOM that I'm going to show you coming up in a few minutes. Here's a view of the BOM attributes. Now this is just the raw data. So this is the subset of the JSON BOM that is stored on each line item. Of course, this can be parsed, prettied up, shown in a pretty way, either on your quote document or on the user interface to the user. But I just wanted to show you what it looks like here by default. So just to remind you how we got here, here's our BOM attribute mapping table. For this size, we took we mapped the size configuration attribute to this BOM attribute. So the user picked large. This is a large pizza. So we have that attribute large. And there happens to be a translation that's set up in our BOM tables. So in Italian, size is dimensione. I'm sorry, I butchered that. And large is grande. So again, the labels, the attributes, and the translations are all available to us for use throughout the system, again, whether it's on the document, whether it's integrations, or whether it's on the UI itself. Another quick example is these cooking instructions, where we're dropping those cooking instructions for a well-done pizza and telling the system that we should bake it for an extra 5 minutes. And again, this metadata can then be used downstream in the fulfillment system when we actually convert this quote to an order. All right, so now a few words about sales BOM pricing, which we touched upon a little bit. I mentioned that typically the price, or I would say the happy path, is that the price of a sales BOM is the sum of the price of its parts. So let's go back into configuration and spend a little bit of time talking about this pricing table on the upper right side. Now, the BOM rules introduce a new kind of line item on this price summary called the total price of BOM. In this case, it's $6. So this total price of BOM is the sum of the price of all of the BOM's constituents parts. Now, in this case, because we did some dynamic mapping and overwrote the prices, the sum of the prices is not the price of the whole BOM. We have other price components here. So now let's just take a quick look at which of those components, BOM components, are actually priced from the item database. And it's these three. The crust is $3, and on the right side, we see the crust, the item detail of the crust as it looks in CPQ, and we see that its price is $3. And again, this would be normally sourced from your ERP system when we're doing an item integration, item synchronization. We're also getting the items prices. And so again, the happy path is that the price of your BOM is the sum of the prices of its constituent parts. And it just so happens that in this particular case, it's these three parts that add up to $6 as our sales BOM price. Now, going back into configuration, we added a couple pricing rules to summarize some of the dynamic pricing that we're doing so that the numbers add up. So all of our toppings add up to $2, and our base price for our pizza, our large thin crust pizza, is dynamically calculated at $15. And remember, we mapped these two values, this base price and these topping prices, to the individual BOM components and line items. That $15 and $2 sums up to be $17, and if we go back and see our line items, it is those items that we mapped that get those prices. So once again, so it's clear, we map the base price configuration attribute to our list price line attribute, and we're doing that on our pizza top level item. And we're doing a very similar thing for our topping child items by mapping the topping price. So in this way, we're able to implement dynamic pricing. One more thing, we also have this recommended item. Now, those of you that are existing users of CPQ, you know what these are, but recommended items are basically the classic way by which we craft a sales BOM using CPQ. It's a type of rule where we translate configuration state to line items. Now, BOM mapping does the same thing in a way, right? The sales BOM ends up as our line items, but you could use both recommended items and sales BOM rules simultaneously. So in this case, we are kind of upselling a 2-liter soda for $2 as a recommended item. Now, this 2-liter soda is not going to be part of our manufacturing BOM that we're generating as part of this. It's just an extra thing on the side. Now, it could be used, you know, we could, using the JSON functions, we could inject potentially these extra items into the BOM, or we could just sort of parse that in middleware at the time of integration and so on. So there's a variety of different uses for the combination of both the new BOM mapping rules and the traditional recommended item rules. And that recommended item, if we go back to commerce or the line grid, we see comes up as an item at the end there after our BOM items. Notice that for the recommended item, the BOM attributes are not set. So this one doesn't have any BOM attributes because it's not actually part of the BOM. It wasn't generated as a result of a BOM rule. Now, I wanted to go back to this is to talk about like the ultimate blow-off valve that we have in terms of manipulating the BOM that is generated automatically by CPQ, and talk a little bit about the detail of the BOM rules. So remember, I talked about how this crust description was dynamically generated. There's a variety of different ways to do it. I decided to do it in the most difficult way possible, just to have something to show you. So this crust description is actually generated using an advanced BOM rule, and we'll see what that looks like. So let's navigate to our administrative view. We're going to look at our product catalog definition. Here we have are basically all of our configuration attributes and configuration rules for our pizza configurator. And notice that we have two different BOM mapping rules, and we're going to look at both of them. The first one is our simple table-based one, and the second one is the advanced one that we use to generate that description. So taking a look at the table-based one first, and the first time I saw this, I was surprised at how simple this is. I mean, all it is you tell it which top-level item you want to generate and which commerce process that you want to add the lines to. That's it. No BML, no nothing. You load the tables, you create this rule, and the BOM will start being generated based on those tables, period. Done. Minimal effort in terms of implementation. Now, the second rule is an advanced rule. And like I said, I call this kind of a blow-off valve. Always, there must be a way. If you can't do something in a table-based rule or using the dynamic mapping, you sometimes have to drop into BML. So we're going to look at what this BML does. We can look at the edit function here. And this is doing something very simple. What it's doing is it's grabbing the BOM instance, which is always available to us in configuration. This is a JSON. It's querying it, grabbing the crust sort of element or component, and it's augmenting the description field with a dynamic description, and it's concatenating size and crust. So that's how we got size and crust into the description using this mechanism. So you can have any number of rules that kind of act additively in order to manipulate the standard core BOM that is generated using your standard table-based rules. So we've gone through an example of how all of the BOM tables work and how they map to configuration. Now I'd like to just say a few words and provide a little bit of guidance to those of you that are existing users, existing customers of CPQ. Some of these are little gotchas. So you might have noticed that the tables, they're monolithic. Unfortunately, with this version, you don't have the ability to chunk up the BOM, any of the tables, whether it's the item definition, item mapping, attribute definition, and so on. These are single large tables in CPQ. So if you have a process where you have different product management people that are managing different subcomponents or portions of the BOM using different tables, you have to put it all together externally and put it in. Now, this is less of a problem if you're sourcing this table kind of programmatically, right? If you're integrating this data with an ERP system, then that data integration is gonna transform your ERP data into that single into the single tables that are expected in CPQ. Now, again, this is, I think, only a problem if you're managing these BOMs directly in CPQ. Another thing is that the sales BOM is not displayed during configuration. So you notice that there were no line items. It was only just the total price that was displayed. This is unlike the recommended item rules before, which you're able to display the individual components. With the BOM mapping, it's only when you actually add the configuration to the quote, that's the point when you see the line items. So the workaround for this is to actually just provide use an HTML attribute to display the sales BOM during configuration. There is a system attribute in configuration that's available to you that you could parse using the JSON functions, turn that into an HTML attribute, pretty it up, and display it there. The other thing is that mapped dynamic pricing is not reflected in the BOM total. So you're forced to use pricing rules or other methods like dynamically displaying pricing information just using attributes because those mapped values are currently only shown once that quote is created, or I'm sorry, once that configuration is added to the quote and you see it in your line item grid. You also cannot add a whole subassembly at once. So you might have noticed with the cheese item that we were adding, we had to add cheese and all of the cheese's subcomponents. This is a little annoying. It's not a showstopper, but it's a little annoying, right? So the workaround is that you just have to brute force and add all the child parts. It clutters the data a little bit, but again, it's not that big of a deal, I don't think, if you are actually doing the data integration and sourcing the data from an ERP system. Another little limitation is that array attributes can only be mapped once. And I really discovered this when I was trying to add that cheese component, which itself has some subcomponents, all the ingredients of that cheese. And I tried to use that topping attribute for all those subcomponents, and I couldn't. You're only able to use the array attribute once when adding an item. So the workaround for that is to use helper attributes. You create another attribute which you populate. You kind of summarize the stuff that's going on in an array, and you use that in your BOM item mapping or attribute mapping instead. The BOM tables are also a simple equivalence in terms of the condition, specifically the mapping tables, right? So when we're defining in the mapping tables the configuration attributes and their values that would result in a particular item, you only have one column to work with. It's configuration attribute and value. But if your condition under which you want to add that item is more complex, well, then you have to define a helper attribute. That helper attribute is generally set by the system instead of by the user. So an example of this would be that dynamic description, for example, for that crust. Where we had really two attributes that were doing it. We had the crust size and the crust type. We would use a helper attribute, concatenate those two values, and use that in our mapping table, specifically the attribute mapping table. And those are some limitations that I came across that I think you should be aware of if you are a existing CPQ user. So we've come to the conclusion of the presentation. I see there's a few questions that came up so far. We have a few minutes left here, 8 minutes, for Q&A. So if you have any questions, please message them to Devang. The first question was, does a BOM item need to have a valid part number? Now, sales BOM items do need to be parts in CPQ because they're line items in CPQ. Manufacturing parts, according to the documentation, and I'm going to be honest with you guys, according to the documentation, the manufacturing parts don't have to be manufacturing only parts. If an item is both a sales part and a manufacturing part, then it would have to be, because the sales part always needs to be a item in the CPQ items database. But if it's a manufacturing only one, it shouldn't have to be. However, I find that it still does. I'm confirming with product management whether or not this is a bug. I haven't gotten an answer yet. This might be a bug, because everywhere in the documentation it says that manufacturing items do not have to be parts. Now, there's some workarounds for this, right? Something could be an item in CPQ and not an item in ERP. Although that's not ideal, right? Because then you just have a little bit of divergence. But I've certainly come across situations where, that was kind of the solution. Because if you treat CPQ as your master system of record for your sales BOM and how you sell your items, whereas your ERP system is your master system of record for how you manufacture items, then you might have that divergence in the items. The next question is, if you're pulling your data from ERP, is it still possible to add the advanced description functionality? Yes, absolutely. So again, by default, the items, the item description is pulled from the item database in CPQ. Generally speaking, that item database is sourced from your item master, which is going to be your ERP system. And you could always overwrite that standard base description using a variety of different mechanisms. So we saw two different mechanisms, either through the attribute mapping, by simply writing to the description field, so that you could use a helper attribute to dynamically generate like a dynamic description and drop it into description_line and use that in your quote document or your output, or you could potentially augment the BOM using the advanced BML-based BOM rules, as we saw. Those are the two questions that I have in front of me. Were there any other questions? We have 5 minutes left.
Yeah, if you have any questions, you can send it via chat window to me, Devang Bausar, or if you have questions afterwards, you can email them to cpq@accelalpha.com.